The functions f and g are defined with the respective domains by f of x is equal to 3 cos half x for x between 0 and 2 pi, and g of x is equal to the modulus of x for all real values of x. Find the range of f. The inverse of f is f minus 1. Find f minus 1 of x. Solve the equation f minus 1 of x is equal to 1, giving your answer in exact form. Write down an expression for g of f of x, and then sketch the graph of y equals g of f of x for x between 0 and 2 pi. Describe a sequence of two geometrical transformations that maps the graph of y equals cos x onto the graph of y equals 3 cos a half x. So it's a really long question, this, isn't it? Let's have a look at it. I've written it in summary form. The first thing is it says find the range of f. Here's f. So let's do a little sketch of this. It's the cosine function between 0 and 2 pi. So if we do a quick sketch of cos half x, instead of going down to 0, cos of 0, if you put 0 in here, you get cos of 0, which is 1. 3 times 1 is 3. So it starts off at 3. And then when you put pi in, you get pi over 2, which is cos 90 is 0. So it goes from the 3 down to 0. As x varies from 0 to pi. So the cosine function is basically stretched out by a factor of 2, isn't it? And scaled up by a factor of 3. So we know the cosine continues to go down. Let's just continue the pattern of the function then. This is 2 pi. And let's confirm that. If you put 2 pi in here, half of 2 pi is pi, and cos of pi is minus 1. So that would be minus 3, wouldn't it? So there's a little sketch of that function f then, here on this little sketch. So find the range of f. Well, we can see what it is, can't we, as x varies. So part A, which will put the answer here, range of f then is equal to, and it's going to go from minus 3 to 3 inclusive, isn't it? So the inverse of f is f minus 1. Find the inverse of f. So let's have a look at that then. So, okay, let's go down the page then. We need to find the inverse of f. It's 3 cos half x. So y is equal to 3 cos half x. So that tells us then that cos half x is equal to y over 3, and that tells us that half of x is equal to arc cos of the y over 3, inverse cos both sides, and finally we can now read off that x is equal to 2, move the 2 up to times on the other side, cosine minus 1 of y over 3. So f minus 1 then of x, change the symbols from x to y and y to x. So it's 2 cosine minus 1 x over 3, and it's defined, let's put the domain defined on, and it would be, of course, the range of f would be the domain of the inverse function, and the range was minus 3 to 3. Okay, so that's that. So now that's the f minus 1 of x. Solve f minus 1 of x is equal to 1. So let's have a look at that. So part 2 now of b. So this is b, part 1 and part 2 now. So we need to solve f minus 1 of x equals 1. So let's have a look at that. So we've got 2 cosine arc cos minus 1x over 3 is equal to 1. So that tells us then, take the 2 from times the divide, arc cos x over 3 is equal to a half. Take cosines both sides, so that gives x over 3 is equal to the cosine of a half. And then that tells us that x is equal to 3 cosine of a half. So that's that part done then. So we've got the value of x, 3 cos a half. So next part then, part C. write down g of f of x. G is the modulus function, isn't it? So part C, g of f of x is what we need to write down, which is g of 3 cos over half x, isn't it? Which is equal to the modulus of 3 cosine, because g is the modulus function, so it's the modulus of the something. So it's g of f of x then. Sketch g of f of x from x equals 0 to 2 pi. So we actually sketched the 3 cosine above, didn't we, at the beginning of the sketch? And we said it went from 3 down to minus 3 from 0 to 2 pi. But basically, because we're talking about the modulus now, what happens is that this function can just come back up because we're taking the positive values like so. So there's our modulus function then. This value here is pi, and this is 2 pi, and there's our x-axis and our y. Okay, we get that. C part 1, C part 1 and C part 2. Okay, so we've done that then, and then describe the sequence of 2 transformations, so it's a separate problem now for part D. Mapping y equals cos x to y equals 3 cos half x. So y equals cos x maps to y equals 3 cosine half x. So cos x going to cosine half x stretches the curve by a factor of 2, doesn't it? We saw that above when we did this original sketch. In the horizontal direction, about y. What to do in the horizontal direction? About OY axis. About the OY axis. Okay, so that's that first transformation. Then the cosine half x to 3 cosine half x stretches or scales the y values up by a factor of 3. About the x-axis. So you got this one, it stretches it horizontally by a factor of 2, and then after that, if you then go from this plot to this plot, it's going to scale it up vertically up or down, vertically, so it's better word is vertically, isn't it? Value vertically by a factor of 3, about the x-axis.